Hello pre-algebra, and welcome to lesson 8.4, where we do some more two-step equations, some more word problems, and just some regular problems. We're going to add a little twist. Sometimes we're going to need to use the distributive property to help us solve some of these problems, and we're going to take a look at that. So that's what we're going to be doing today. So let's get started. So here we have another word problem, right? And we're going to notice that this we're going to have to use the distributive property. It's going to be helpful to use the distributive property um, to solve this problem. So let's take a look at it. A bowling alley charges $3 to rent shoes. 4 friends each pay for one game and for renting shoes. The total cost is $28. You can solve the two-step equation for open parenthesis x plus 3 close parenthesis equals 28 to find the cost of the game. But before I do that, although we were given the equation, let's go ahead and see if we can figure out the components of this equation. So let's do like we were doing in our last lesson. Let's look at this. Where is our equal sign? So here it is. The total cost is $28, and that matches this part of the equation. Okay. So bowling alley charges $3 to rent shoes. So $3. There's that $3 there. 4 friends. We're going to use a new color here. We're going to use light blue. 4 friends each pay. So that is the 4 there. For one game and for renting shoes. So that is 4 friends pay for one game. That's going to be our X. We don't know how much each game costs, but they pay for the game and for renting shoes. And we know, here's the renting shoes, we know that the renting shoes is $3 because it says that right here. So those are the components and where we found them in this problem, right? Again, if we write this out, we have our 4 friends, and each of them has to contribute for the cost of the game and for the shoes, so we add those together. And each of them, therefore, the total each pays is $28. Okay, so how do we solve this now? Because we were told to find the cost of the game. So how do we solve this? Well, we could, right? If we look at this and we think of order of operations going in reverse order, another component of the order of operations, remember, is we always do, normally we always do what's inside the parenthesis first. But when we're undoing an equation, right, and that's what we're trying to do, we're trying to undo the equation to get x by itself, we go in the opposite. So that means we're going to start on things outside the parentheses. And what's taking place outside? Well, we are timesing 4 by whatever is going on inside the parentheses. So if we do the opposite of multiplication, we're going to do division. So that means we're going to divide this by 4, and what we do to one side, we have to do to the other side. We're going to divide 28 by 4. Now in this case, those 4's cancel out, leaving us with x plus 3 equals, and 28 divided by 4 is 7. And now we isolate x again by subtracting 3. Oops. Right, which leaves us with x equals 4. And then we could always check it, right? Because that's our solution. And it's always good to check our answer, our solution. So let's try that. 4 plus 3 equals 28. Remember, regular order of operation, we do what's inside the parentheses first. So 4 times 4 plus 3 is 7 equals 28. Oh, look at that. 4 times 7 is 28 equals 28. All right. Another one. DeAndre is ordering tickets to go to a concert. He buys 3 tickets that all have the same price. There's a service charge of $4.75 per ticket. The total cost of his order is $111.75. what is the price of each ticket. So we are solving for tickets. So let's go back and see if we can set up our equation. So do we know where the equal sign is and what one side of the equation is, what the total is on one side? Yes. Here's the is, right? The total cost, that whole sentence. But in particular is, so we're going to go ahead and write that over here, is 111.75. So we got that part down. Let's see, so he's ordering tickets. He buys 3 tickets that all have the same price, and there's a service charge per ticket. So we don't know what tickets are. That's what we're solving for. So let's just use T to stand for ticket. So T, but the total price to order these tickets is the ticket price plus, right, this service charge. Go Ticketmaster. So T plus, I'm going to use actually, I think, a different letter since my T looks very similar to my plus sign. Excuse me. Let's just use X. Okay, so X plus the cost, this additional service charge, $4.75. And he's buying 3, and all 3 are the same. So that means we're going to put this in parentheses and times whatever that is by 3. So there's the 3 tickets, or him buying 3 tickets, right? They all have the same price. Here is the service charge. So there's the 4, there's the 3, and there is our equation. And of course, we don't know, oops, wrong color. We don't know what the ticket costs. Right, we don't know what the ticket costs, but we have ticket representing X there. So again, we figured out, right, that regardless of if he bought 6 tickets or 1 ticket, it was going to be the cost of the ticket plus $4.75 per ticket. So if you bought 2 tickets, it's going to be 2 tickets, right? So it's going to be ticket plus $4.75 times 2 because you bought 2 of them. If you bought 5 tickets, it's going to be ticket plus $4.75, right? Added that together and then times that by 5. In this case, it was 3. And that's what we have here. So now we just go ahead and solve it. Now this is interesting, right? Sometimes we're going to find out that it's going to be hard to divide the number on one side of the equation, like this one here, by our number that's hanging out outside our parenthesis, this number here. Sometimes. In this case, $111.75 or 111.75 is divisible by 3. But sometimes we may look at that and we say, I don't know, and you don't have a calculator, so don't know. That's okay. I'll show you in our next example what to do about that. But in this case, just trust me that we can do this division. So we are going to go ahead and do it. Let me get rid of those red circles. And so over here, we're going to divide by 3 to get rid of those 3's, and we divide by 3 over here. So our new equation now is going to be X plus 475 equals, and 111.75 happens to, divided by 3, happens to be 37.75. Oh, excuse me, 25. And now we know what to do next, right? Now we subtract by 475. That gets rid of that. That isolates our X, which means that we also have to subtract 475 over here. So that leaves us with X equals 32.50. Again, we don't necessarily have to, but it's always a great idea to check our answer, plug that back in, and figure it out. I'm not going to do it here, but that's always a good thing to do. So each ticket costs $32.75. So our answer, right, there's our answer. Each ticket costs $32.50. All right, so here's a situation where we need to use the distributive property and go ahead and use it by distributing 6 into the parentheses to solve this, because 6 does not go into 15, right? 15 is not divisible by 3. Sorry, so 15 is not divisible by 6. 15 is divisible by 3. But it's not divisible by 6. So we can't just do like we might, right? We can't just go divided by 6 divided by 6. That doesn't give us a whole number, and therefore it's going to generate some problems. This is the easier way to deal with that, and that is to send that 6 into the parentheses. Go ahead and solve that, distribute that 6 into our parenthesis, and then solve for y. So, right, if we distribute 6 into our parentheses, that's going to be 6 times y, which is 6y, plus 6 times 4 is 24. We've used the distributive property here, right, to distribute 6 into that equation, and it still equals negative 15. All we did is we did some of the operations on this side. We didn't undo an operation. Now we can begin to undo operations, and in this case we're going to undo the plus 24. So we're going to subtract 24 on that side. So on this side we're going to be left with 6y, and on this other side, right, we have negative 15 plus negative 24, and that is going to be a negative 39. Now we have to get rid of that 6 still. So how do we get rid of the 6 on this side? Divide by 6, divide this side by 6. In this case, those cancel out, and so we now have y equals. So what are we going to do with negative 39 divided by 6? Well, I don't think that's going to go in. You may pop it into your calculator, right, and you're going to get a decimal. And we don't necessarily, we're not looking for a decimal here. We're looking to simplify. So 6 goes into 39, right? If you did this in your calculator, you're going to find out that 39 divided by 6 is 6.5. So we could write it as 6.5. I use a different color here real quick. This is this is negative 6.5. We could, and we just need to know if we're being asked to write it in decimal form or in simplified form. In this case, we want to write it as a fraction. So if we know what 6.5 is as a fraction, if we know that 0.5 is 1 over 2, then that is a simple way to do it. Negative 6.5. Remember, the other way we could do this is we could do some long division. 6 goes into, sorry, I can't set that up right. 6 goes into 39 6 times. 6 times 6 is 36. That leaves me with 3. So that means that I have 6 and 3 over 6. I simplify that 3 over 6 into 1/2, which gives me 6 and 1/2. Okay, so that is our answer. I hope you followed along. If not, send me an email asking for clarification, and I can give you a little clarification, or hopefully this next example will clear things up for you. So last one, this is a word problem which we have to set up an equation, our last example. Brody drives the same distance to and from work each day. He also drives an additional 1.5 miles each day to go to the gym. During a 5-day work week, Brody drives a total of 71.25 miles. What is the distance to and from work? So again, let's look for that equal. Here is what it equals in particular, 71.25 miles. So our equation on one side has 71.25. All right, so what is going to go on the other side? He drives the same direction or distance to and from work each day. What is the distance to and from work? So we're looking for that travel to work, to and from work. So it says that he drives to work and home, and that is a set amount that we don't know. And then he adds an additional 1.5 miles each day to go to the gym. Okay, well, we can deal with that. So that is, it drives an additional. Additional is going to be a plus. So that is plus 1.5. And we're going to be adding that to whatever he does every day. Okay. We don't know what he does every day. So we need a variable now. So let's use D for that distance to and from work each day. We don't know what that is. But we know that D plus 1.5 is what he drives every day during the week. Now our total here, right, is that, right, we got to go back up here. We found our total, but it's for a 5-day work week. So I'm going to write that in a new color. This 5-day work week means that this has to be multiplied by 5. Because that 71.25 is not for the day, that's for the 5-day work week. So that 5-day work week is represented here by multiplying what he does every day by 5. So let's rewrite that. That is 5 times the distance to and from work plus the additional 1.5 miles to the gym. And that happens 5 times a day, and at the end of the 5-week day, he's driven 71.25 miles. So there's our equation. Now we just need to solve it. So if we get out our calculator, right, and we do 71.25 divided by 5, we get a fraction. So let's not do that fraction, 14.25. So let's not use that fraction right now. Let's instead go ahead and distribute the 5 into our parentheses and then do the subtraction and division later. So in order to do this, we're going to divide this side by 5. Oh, sorry, we're not going to do that. We're going to distribute. I just didn't realize this. Right, we're going to distribute. So we're going to have a new equation. We're going to have 5d plus 1.5 times 5 is 7.5. And that's going to equal still 71.25. Now we can subtract that 7.25. Right, that's going to be the next thing we do. We're going to subtract 7.5 to get rid of those. And we're going to have a new equation. We're going to have 5d on one side, and 71.25 minus 7.5 is 63.75. And then we're going to go ahead and we're going to divide. I ran out of space here, but we're going to divide both of these, right, by 5, leaving us with d equals, again, 63.75 divided by 5, 12.75. So that means that every day, or that means the distance to and from work is 12.75 miles. All right, and that's our lesson for today. So go ahead and do your ALEKS work, and ALEKS 8.5 homework. And again, if you have questions, go ahead and shoot me an email, and I'll try to answer your question. Have a great day.